Today I've got something really special for you, a comprehensive guide to import your Apple Health data into your Tana graph and making the most out of it. We are not just pulling the data, we are taking it a step further. We'll convert your Apple Health data into neatly organized Supertag Tana nodes. This way, your health metrics are not just numbers, they become actionable insights that you can track and visualize directly within Tana. But that's not all. I'll also walk you through setting up specific goals, such as your daily step count or mindful minutes, and show you how to visually compare your actual data against these goals. If you're looking to elevate your use of AI with the power of Tana, this tutorial is definitely made for you. So grab a seat and let's transform your health data into meaningful, actionable Tana nodes. First, download the Auto Export CSV plus JSON app from the App Store. And remember that the automation feature is part of a plan that is USD 5 per year. Now you can open the app, and the first thing you want to do is grant access to your health data. At this point, you have the option to set up the units for your metrics, but you can safely skip. And you will be presented to the main interface. In the main view, you can now switch to the automation section, and then you can click on Get Started. And you can create now a new automation from the Automations tab, and I'm going to rename it. I'm going to call it Tana, and I'm going to then enable it. The automation type is going to be Google. Now I need to connect my Google account to continue. Now that the connection is done, I can reopen the app and I can specify a folder name for the data storage. The integration will create this folder if it doesn't already exist. You can then skip the data type settings and click on Select Health Metrics, and here you are going to choose the specific data you want to import. For this tutorial, I'll select all the metrics I need. I'm going to select also mindful minutes, respiratory rate, and sleep analysis. Okay, I think we're done. I'm going to keep the format as JSON, the period as day, and the aggregation as days, and the sync cadence I'm going to use quantity 1 and days 1. I have an error, probably because I need to re-enter the folder name. Let's see if clicking enter will work. Yes, you can see that now the sync is successful. You can see that now I have a new folder in my Google Drive and it's named Health Auto Export. Within this folder I have two subfolders: Health Data, which contains my personal data, and Health Video, which we created right now for this tutorial. Inside the Health Video folder you'll find the JSON files that the app has already downloaded for us. This completes the automation step. We have successfully set up daily imports of the JSON dumps to our Google Drive, and now we are ready to create a scenario in Make to monitor these files and import them in Tana. We start the scenario by downloading a file through a Google Drive action. While we are testing the integration, it's easier to use the download file action. This ensures that when we click run once, we download a given file and send it through the scenario for testing. However, in the end, we will change the first action from download a file to watch files in a folder, which will automatically watch for new files in the folder and send them to Tana without manual intervention. So now the first step would be download a file action. Then connect your Google account. My account is already connected. Then I need to select from list my drive, and we go and select the folders for our integration. So it would be health auto export, health video for this video, and now we can select one of the files that we have got from the integration. Let's run once, and you can see that the bundle was downloaded and the output is there. And most importantly, let's find out the data is here, is in binary. But now in the next step, we are going to convert it to XML. The Tana Input API doesn't really love this JSON, so we will need to convert it to XML to make it more accessible. And we can use the JSON action for this. And there is a default convert JSON to XML. The JSON string will be the data from the Google Drive action, and we can click OK and run once to test it out. Let's see, run anyway. You can see that the file was converted to XML. Now, Tana Input API doesn't really love these HTML strings that are in the XML, so we need to clean this up. We can use an HTML text parser, HTML to text, and you can see that if we run once, the XML will be cleaned up, and now we have only a bunch of text that it's perfect for us to send over to Tana. Let's use an HTTP request, let's use a make a request, and the URL will be the endpoint of the Tana Input API. The method will be post, the header will be authorization, and the value will be bearer, and the API token that we are now getting from our workspace in Tana. I'm using TNXP. I'm gonna copy this one, go back to make and paste it next to bearer. Perfect. The body type will be raw, the content type will be JSON, and the request content will be the payload of a Supertag that we are now going to generate. So now we need to generate a Supertag for our health dump. I'm gonna call it health dump 1, and I'm gonna convert it to a Supertag, and I'm going to configure this Supertag. I only need one field. I'm gonna call it data dump, and then I can simply with Command K show API schema, and there you go, my payload is over here. I can copy the payload and I can now go back to make and paste it in the request content. Perfect. Now I want to assign a given title to the dump. I want it to be called health data dump. The value of the only field that we have for our Supertag is gonna be the text, and we can remove this child node that comes with the default payload. You can simply remove it. Okay, and now we are ready to test. We can click on run once, and we can see that the status code is 200, and this means that the node was sent over to Tana. Let's go back to Tana. Let's look for health dumps in our workspace, and there you go. And you can see that the data dump is filled with our data, and this is perfect for us. GPT is able to do wonder with this data dump, and I will show you in a second. We have our data dump in our workspace, and we can now start building the commands workflow to process this data. I'll name this node process health data, and I will convert it into a command node. The command will have 3 steps. The first step will be process data states. The first thing basically we want from the AI is the date of the data dump, which in this case is October 2nd, 2023. We'll need a prompt with an ask AI command, and the prompt will search in the XML to find the date. So we need an ask AI command and a prompt. I had to modify the prompt quite a bit because it was constantly returning the right date but with the time set to midnight. After adjusting the prompt, it works as intended. I'll create a new field. I'm calling it dump date, and this will serve as a target for the output date. I'm gonna use GPT-4 as the model because it's simply better. And the insert output strategy will be replace content. I can test, and you can see that the dump date now is correct and is in Tana based format. It works with the Tana calendar, so we can go on with the second step, which is the actual data processing. Again, we need an ask AI command and a very tailored prompt. Prompt specifies that the XML tags lack a precise structure, which we discarded in the make process, and so it needs to be interpreted by the AI. After loads of trials, I settled on a prompt that gets interpreted just the way I want, again by GPT-4. And the example output is going to be quite straightforward. It will return the name of the entity that I am tracking, the data dump date, and any activities selected in my dump. I'll also include totals where I need, basically everywhere. So the XML is going to be the data metrics, and the example output is going to be now my activities. In this case, it's going to be activity energy. I'm going to say that I want the activity energy Supertag applied to it, and then I'm going to input any other information that is related to that active energy indented. And so I need dump date field with the date. And if it's enough like this, because the AI is going to generate the data metrics for you. You can, however, add a total and the metric units to make it even more specific. I'm going to do that for all of my data metrics. And then I'm going to use insert output strategies as child. I'm going to use GPT-4 as the model, and I am done with the process. I can now test and see what comes out of this AI command. Let's see what happens if we run the process health data now. The first step would be processing the date, and the second step would be the actual data processing. So the first part is outputting the data into dump date, and you can see that now we have our super tags generated. You can also see that the total is added to every entity. I can now simply promote these fields to the super tags, and that will be automatically generated in my graph. You can also see that the metric units are fine, even though I didn't include the example on each one. And now I can create title expressions so that they would be nice and visual for me. I want the name, and of course I want to include the total in the title. I can include simply by referencing the field, and there you go. I can do the same for all my entities. I'm gonna do the same for audio exposure. And now for stand time, I want to track. I want to set a goal, which will be the goal I want to reach each day. And I'm gonna say 120 minutes. And then I can set a status, a goal status. This will be an AI enhanced field, and we are now going to configure. So we use a custom prompt, and I'm going to show you a very neat prompt that is going to return a nice visualization of the percentage of your goal, basically. So the goal status is going to look a lot like this, and the output is left to the AI. And I can now run goal status, and you will see that the percentage is on point. I can do the same for step count. I can include the goal status. The goal here will be 5,000 steps, and I can run the AI field. That's cool. And I want to do the same for mindful minutes. I want to add a goal and a goal status. There you go. Okay, perfect. Now I want to display these in my titles. So I'm going to create another title expression with name. I'm going to use an arrow, and then I'm going to include the total and then the goal status. So I'm going to reference the total field and the goal status. There you go. You can see them now, it's much nicer. I can do the same for my other entities. Stand time as well. And that's it. Now for sleep analysis, there is a slight change. Notice that we don't have a total field, but we have a sleep field. I'm going to include goal and goal status. I'm going to set a goal, but then you will see that if I run the AI field, it will say that the total field is not present. So the first change that we need to do here is for the goal status. We need a different goal status field with a different AI prompt. So we can copy the prompt so we do easier. Then we can create a new goal status field like this. I'm going to make it an AI enhanced field, and I'm going to pass the prompt. Now, in a perfect world, clone reference would work in bulk, but it does not, and I don't really want to do this for all of these lines. So let me just quickly create a new command. I'm gonna call it bulk clone. I'm going to convert it to a command node, and I'm going to use a run a command line command, and I'm gonna use the command line command clone reference. Now if I run this over a bunch of nodes, it will clone them in bulk. This was a nice extra for the video. Okay, now should be good to go. I need to edit total and it should be asleep. And here it should be asleep. And now if I run the AI field, it's working. It's not displaying the percentage. That's weird. Anyway, I wish it would be possible to select GPT-4 for AI enhanced field. It would be much easier to do these types of workflows. Let me try again. This is most likely, yeah, you can see that this most likely it's working sometimes, but sometimes it's not. I can include the goal status in my sleep analysis, and I'm done. Now what I want to do is I want these AI fields to be automatically processed or run when I click process health data. And so I'm gonna add an additional command. I'm gonna call it run AI fields, and it's gonna be a run command on all children, and the command is gonna be run AI fields. Run AI fields, there we go. I don't need to add any configuration because it's just running all the AI fields that it's finding in the child as childs. Let me quickly test this one from the start. So click process health data, we get the data date, and after that we get all our nodes and the AI fields are run automatically. This is it. The workflow is complete. We can now add a couple of additional commands. We need a processed field so that I can mark this node, or better this dump as processed. And I also want a command to do this so I can mark the node as processed. And I'm gonna use the check mark, convert it to a command node, and I need a node filter so that this command will be visible and usable only if the processed field is not checked. And the actual action will be set field values, and we need to set the processed field as checked. There you go. Now when I click the command, the node is marked as processed and the processed button is not visible anymore. And I also want to filter the visibility of the process health data command, and so I'm gonna use again a node filter and say that when the processed field is not checked, then this command is gonna be visible. Otherwise, I don't need this to be there. And so I can simply select the processed field, and when it's not checked, then the command is gonna be visible. There you go. This is the whole workflow. We need to go back now to make sure that we edit the action. The first step should be watch files in folder. And I'm going to move the clock to the new action, which is the watch files in folder. And then linking the two blocks, the two Google Drive blocks. And now I need to select the folder to be watched by the first step. So Alt Auto Export, Health Video, and I'm going to limit to 1. Click OK, and now here I can simply edit the enter file ID to enter manually. I can delete the file ID and select the file ID from the first step. Click OK, and we are done. I can click run once, and The workflow is running perfectly, the status code is 200, the node is in Tana, and we are all set. Alright folks, that brings us to the end of today's tutorial. I hope you found this guide useful in importing your Apple Health data into your Tana graph. If you have any questions or need further clarification, don't hesitate to reach out. And remember that the make scenario and the template for this whole workflow is available in the Discord community right now.